All right, we have an object of mass 5 kilograms. Here he is, 5 kilograms, projected vertically upwards. So the initial velocity is 40 meters per second, and there is a resistant force. So we know, first of all, that we have mg, or 5g in this case, going down, but we also have this resistant force of 0.2 v squared in newtons. So we know mass is included because it said newtons. So when we're setting up our acceleration equation, we've got mass times acceleration, so 5a in this case, and we've got this negative mass times gravity, so 5g, and we've got this negative 0.2, which is the same as a fifth v squared. So we've got that going on. So when we do divide through by the mass, we get minus the gravity, and in this case I think we're told, yep, to use 10, and we've got, so this will be a fifth, so it now becomes, that should be squared, a fifth divided by 5 is now 1 on 25. All right, so we have all of that going for us. If we make a common denominator, you can see we've got minus 250 minus v squared, which is what it wanted us to show for dv to t. So if we now use that, we're looking for the maximum, the time of the maximum height, and we know that that occurs when velocity is 0. All right, so we are looking for time, so we can stick with this formula here, except we need it to be, sorry, this form, we need it to be upside down. So if I make that, and actually I'm going to put the minus up there and make this all nice and positive. All right, so as it starts and goes up, we're going to go from 0 up to, sometime t. So when I integrate with respect to t on this left side, I'm going to get a t. I'll just put this here. So t will be equal to. On this side, I'm going from a velocity of 40 all the way up to when it reaches 0. So you can use a definite integral, or you can do your plus c. Either way is fine. Oops, in this case. All right, so minus, and then I'm going to have a dv on 250 plus v squared there. All right, so we know that this is going to be the inverse tan. So actually, and I can change I can not put the minus in, and instead what I can do is actually change my limits to, instead of 40 to 0, change it to 0 to 40, if you want to do that. All right, so when we do inverse tan, we do v on, and we've got root 250, which is the same as 5 root 10, or root 250 is fine. So I also need the 5 root 10 here. And when I put that in, you can see I'm going to simplify that as well. So 5 on root 10, I'm going to have inverse tan of, so 40 on 5 is 8, so 8 on root 10, minus inverse tan of 0, which we know is 0. All right, so put that in the calculator then, and you will get 1.888, so approximately to the nearest tenth of a second, 1.9 seconds. Okay, so that would cover part B. Then in part C, we want to find the actual maximum height. So we know the maximum height occurs when velocity equals 0. So we really need an xv equation. So we're going to go back to our acceleration equation and change it to, we don't really need that, and I'll do it up here. So let's change it to v to v dx, v to v dx. Now we've got an x and a v. So v to v dx, we've got the minus 250 plus v squared on 25. So I'll put the minus out the front. Okay, so if we do that, so we just change the format of our acceleration. Again, I need to turn it upside down. So turning it upside down, I get that again. But this time we've got a v. So again, as I'm going to my max from start to my maximum height, I'm starting at x equals 0 and going to some value x. So this side will be x as velocity again. So I would have minus 25 and v to v here on 250 plus v squared. I can get rid of, and the velocity would be going from the initial velocity, 40, up to 0, but if I get rid of that, I can go from 0 up to 40 instead. And let's just make some room here. All right, so as well as that, let's go back to blue here. We really want a 2 there because the derivative of the bottom is 2v, so I need a 2 here. So you can see I'm going to get 25 on 2, and then I'm going to get a log. So I'm logging my 250 plus v squared between 0 and 40. Alright, so 25 on 2, I'm going to get log of 250 plus 40 squared is 1850. Minus log of 250 plus 0, so it's just 250. Again, if we put that in the calculator, we get 25.0185, which is approximately 25 meters, correct to the nearest meter.